Hello, friends. Welcome to another knowledge sharing series of podcast by TCR Advanced Engineering Private Limited. Today, I am your host, Chiral Patel, corrosion and pipeline integrity specialist working with TCR Advanced Engineering Private Limited. Today, we would touch upon a very fascinating and technological advance on non-destructive techniques called thermography. Thermography is a widely used tool for its industrial applications in oil and gas, petrochemical refineries, and fertilizers industries. We will also touch upon its applications on power and household works along with its medical use. Today, for we have called a technical expert, Krutik Shah, who is expert in 9 NDT techniques by ASNT. Krutik Shah brings a vast knowledge and experience on thermographic services. Welcome, Krutik sir.
Thank you. It's a privilege that this platform has been provided to spread the knowledge of thermography. As you easily explained, thermography is completely new field whereby everybody claims to be an expert. But it is just like any person with a good mobile phone camera or say good DSLR, he claims to be a good photographer. But still for any other lifelong occasions, we do call experts. Similarly, anybody with a point and shoot camera can claim a thermography expert. But it takes nitty-gritty of thermography system to understand and give the correct reading and to identify the correct problems. First and foremost, our human eyes, they are limited to only very small part of electromagnetic spectrum. Thermography and ultraviolet light, they are the nearby band of the spectrums where God has given gift to some another living beings, such as bees can see in the ultraviolet spectrum, snakes can see in the infrared spectrum. But human body eyes are limited to very small spectrum, that is visible light. So here, by going to thermography field, as one of the company has aptly marketed that it is giving us a sixth sense of detection. You will be surprised that in thermography spectrum, there are some spectral or wavelength ranges whereby if you are able to see me in this atmosphere, but if we change to that spectrum, this whole air becomes foggy or non-transparent. Many people don't know this and they say that if I can see through glass, I can see through thermography. No, you cannot see even through atmosphere also. Atmosphere is also non-transmissive. So that is why it requires a good understanding of the subject to give proper interpretation and to give proper justice to the and application of this knowledge to get proper result. Human life, I can say that as a mankind, we always are fighting an war between chaos and system. Everybody wants to have a good system, but there are always chaotic elements present. While increasing our sense of perception, we can identify the chaotic sources and try to systemize them. And thermography can be a very important tool in this. So I hope in good language I am able to explain what is thermography.
So thermography means as per you, it is always been misunderstood. So let's start with basics. How would you define thermography technically and practically?
See, very good question. See, anything above absolute zero emits infrared radiation. So when I say above absolute zero, that is an extrapolated and imaginary term. In the entire observable universe, we have not find a single area where we are able to go to absolute zero. So I can say any object will emit infrared radiation. If I say what is cold, you can say definitely, sir, ice is cold. But ice is cold or 0 degree for our relative scale. But as per our thermography scale, it is 273 degree Kelvin, not degree, but we'll say Kelvin hot. It's 273 degree hot. So it emits infrared. Even liquid nitrogen, liquid oxygen, dry ice, you can claim any cold sources, they emit infrared. If you see the emission of this wave or this particular electromagnetic waves that is based on Stefan Boltzmann law, I will not go with much deep or this podcast will lose its interest. So I would like to say that when the object is emitting infrared radiation, The temperature plays a very important role in its wavelength. Higher is the temperature, shorter is the wavelength. If we see the spectrum, infrared region lies in sub-millimeter range of spectrum. Visible light goes to nanometer range. So if we see, if you heat any object, say for example up to 300-400 degrees, you will see that it is achieving some glow. As you further increase, it will be red hot. If you further increase, it will be yellow hot. At some point, it will be very white hot. Means it is emitting at all spectrum. So thermography is understanding the invisible part of that spectrum. So that is below 300. Thermography is very helpful in identifying the flaws or any anomalies which we cannot see with our naked eye.
So you are saying that it is not just imaging, but it is an analytical tool when used by a professionals.
Yes, definitely. We are studying or we are capturing the intensity of thermography rays to understand. So we have n number of applications. If you can give me or if you can point me to some sector, I can easily explain where we can use it.
So now TCR Advanced is extensively working with oil and gas, petrochemical refineries, and fertilizer plants. Can you please elaborate how thermography is used in those critical sectors where safety and reliability of assets are very important?
Definitely, because that is the biggest sector that is providing largest employment. Fertilizer definitely related to agriculture, oil and gas, yes, everything will not move without oil and gas. So if we see in thermography application lies wherever we have temperature. So I think, can you name any process where temperature is not involved?
No, I am not aware.
I think this can be an exercise to all the viewers also. They can point in the comments or give me where temperature is not important in any of the process. So where temperature comes into play, definitely refinery has got lot of setup, fertilizer industries has lot of setup to maintain a temperature range. Thermography helps in ensuring whether this range is maintained. Even it involves flow of chemical at particular temperature. So if that flow is obstructed in pipelines, we can definitely find with the help of thermography. It will create a small anomaly before creating a catastrophe. So we can go with that anomaly reading even the insulations that help us maintain the temperature. So that insulation loss or even some wet insulation behind cladding, that also we can find with thermography. If you see refractory linings, all these things, they have some degradation. And before the failure, if we can find the degradation and that too in running conditions, I think you are the best person to say that yes, that will be the most helpful part.
So what you are saying is this is done without taking shutdown and online. So how is it?
Yeah, see, thermography involves two kinds of thermography. One is active and one is passive. Active thermography involves, say, for example, if I want to study this cup, so I can do it in two ways. Either I can heat this cup and study how the thermal patterns are or thermal gradients are developing. So that is called as active thermography, where we heat or we stimulate the object and study the flow patterns. Or the other way, just pour a hot tea. So in passive thermography, just without heating, just in natural state or in its running state, we are trying to identify the thermal patterns and gradients involved. So yes, if you say we want to do it running plant, definitely that means a passive thermography. If in shutdown also you want to do thermography, we can go for active thermography.
So let's move to a power sector, substations, generator and switchyards.
Yeah.
How this thermography is used there?
Yeah, very excellent question. In, I think, switchyards and in power station, thermography is the biggest boon that has been detected by modern science or technology. See, in electrical connections, you know, electricity is just flow of electrons, and wherever this flow is obstructed, definitely the electrons will lose those energy, and particularly in the heating region. So if there are some loose connections, definitely it will involve some arcing. If not arcing, then also it will provide some resistance because of some debris. So if we can identify this loose connection or hot connections, we can improve the infrastructure, grid infrastructure, so that we don't have, we have faced some blackouts in past also because of grid collapse. Definitely we can use thermography to identify the switchyard problems, to identify the connections. In fact, thermography can be applied just from power sector switchyard to even our regular switches.
So what you are saying, it will improve a preventive maintenance.
Definitely, yes.
So now let's move to a building sector. Now thermography is gaining a good popularity into a building sectors.
Yeah.
Please explore the civil engineering angle for thermography.
Yeah, in fact, yes. That is the point of initiation for me also in thermography. In fact, in our office, we had a problem of dampness or some moisture ingression. Now, every time we used to say that it may be from the overhead tank, it may be from, say, rainwater or drain water systems, but we were not able to point out the source. So, with the help of thermography, we were able to trickle down to its source and we are able to solve that moisture ingression problem. So, yes, we can find moisture, we can find the delamination in concretes, because at some point, because of corrosion and moisture ingression, the steel rods, they expand, they increase their volume by 4% around, so that will cause delamination and the reinforced concrete will lose its strength and we can see the parts of or pieces of slab falling. So yes, that also can be identified. Even as I told you earlier, in power sector also, if there are some loose switches or loose connections, it is a big source of fire. We have seen in past 3-4 years in Gujarat also. We can recollect the incidents that has happened in Surat, in coaching class fire, even in Rajkot, in that game zone area. So all these areas that can be definitely be prevented had a good thermography inspection had been done beforehand, or a preventive inspection. It would have just take maximum 2 to 3 hours. But yes, we could have been able to prevent that.
So you are saying that it would help in improving household electrical safety.
Yes, definitely. See, 95% of the time the source of fire in any household is attributed to electrical short circuits. Now, wherever the electrical short circuits are there, they definitely give a yielding, what we call in our normal metallurgical terms, a yielding phenomena. That it shows some overheating or not normal heating. If we can identify that source, then we can easily prevent any such fires from building up or from coming in contact with any flammable material. So yes, that can definitely help.
So now let's break down again active and passive thermography.
Active thermography is mainly used wherever we just want to find the hot spots or cold spots. And active thermography, yes, we do heat the object with they are mainly in the range of FRPs and laminates and all that, whereby we cannot say heat them, or we cannot pass anything through them through traditional sources. So we try to understand the flow of heat pattern either through vibration, that is called as vibrothermography, either by some sinusoidal heating sources, we call it as lock-in thermography. So that are different terms of active thermography. In passive thermography, we don't heat the object, we let the process continue and that itself will generate some heat, and we just try to understand the flow patterns in that particular object. In passive thermography, I can further subdivide it into qualitative or quantitative. Qualitative thermography just means that you just take the thermogram of this room and just find the hot spot and cold spots. So that is qualitative. I can just tell, okay, this is hot and this is cold, that's it. But how hot or how cold, that comes the range of quantitative thermography. See, as I told earlier, if you do the inspection in this room also, say particular in this room, definitely this AC will show a cold spot, and the plug area where this AC has been plugged, it will show as a hot spot. That is but natural because electricity is flowing through it. But is it normal hot or it is abnormal hot? So that involves the quantitative radiography, and that involves lot of study of understanding how these thermography waves are captured and how they are analyzed and what correction factors we can apply to give us the correct reading.
So active thermography will help identify the flaws.
Yeah.
So now let's move on to a biological. Does thermography has a biological applications?
Yeah, definitely. In fact, we had, we had one event opportunity. If you can remember the time during COVID, you might have seen at many airports, for screening purpose, this thermographic camera was set up. And in that screening, lot of people who had some COVID issues or they had some abnormal temperature, they were easily screened out. In fact, a lot of study is going on. Not study, I will say it is implemented also to find the cancerous area, even in livestock also. Livestock, we can know that animals cannot speak and express their grief. But with thermography, we can find some inflammation. We can find if that it has a fever. We can do a screening. We all know the disasters that are spread by epidemics of bird flu, swine flu. So all this that can be screened easily with the help of thermography. So yes, in human bodies also to identify cancer, even breast cancers, they are able to identify with high amount of accuracy with the help of thermography. In livestock monitoring, yes, thermography is definitely used. Even in firefighting areas, firefighters they use thermography applications to find the, because they cannot see to smoke, so they have to identify victims that are trapped inside. So there also they have the application of thermography. So I think if you see application wise thermography, your imagination is the limit where we can apply this.
So, if I wanted to ask you, what are the challenges and limitations of this thermography? If our viewers wanted to know.
Yeah. See, one of the biggest challenge of thermography is it is non-contact. So the rays are coming to the instrument through atmosphere. There are lot many challenges involved related to emissivity, means how effectively the object is able to emit the rays. Then we have instrument understanding, and there are 4 or 5 different variables that we need to adjust correctly to get the correct temperature. And biggest source of problem is with low emissivity, it is highly reflective, and that gives us very false spots. So that is the biggest challenge we face in thermography right now.
So, Krutik sir, let's explore a job which we have carried out for one of our clients.
Yes, see, I had the privilege to review some of the images that were taken for one of your client, and that involved a furnace application. Unfortunately, the furnace was in very not so good condition. So there was one hotspot that was reported. But when I tried to evaluate the thermal gradient, first of all, please do understand that all the metallic structures, they are very poor in emissivity values. So when emissivity is less, means emissivity here, it means that it is the efficiency at which it will emit the infrared or any electromagnetic rays that are related to its temperature. And since I told you that metallic structures, they are very poor in emissivity, so they are highly reflective. So when this hotspot that was being discussed, client he used to feel that okay, there might be some refractory issues, or the refractory might be off at that area, and they were planning to have shut down to get that amended. But when I studied the patterns, it didn't show any thermal gradient that we expect in case of metallic structure. So from my side, it was a strong objection, and I said that it is purely reflection. There might be any anomaly. Rethermography was proposed, but I think we didn't have that time window, or maybe the approach was not available where we can do the thermography. So we were trying to find what is the source of that heat. And yes, definitely it turned out to be a local source or heater source that was getting reflected based on the angle. So this shows the difference between a proper thermography and just thermography. In just thermography, it shows hotspot. Conclusion was that refractory was missing. Corrective action was to shut down the furnace and apply refractory parts. And preventive action would be to monitor it every time. But when we studied that image and we found that okay, it is just a reflection. So corrective action, now we will take more than 3-4 different images of that spot from different angles. If there is shift in this image, yes, we can definitely point out it is because of reflection. Preventive action, yes, if we can try to coat it with some high emissivity paint, then okay, then definitely we will not face this problem. So yes, this kind of case studies help us in understanding in proper implementation of thermography. Otherwise, client is always complaining that okay, after thermography it showed some anomaly, but there was nothing there. So yes, such kind of reviews that will definitely help in understanding whether it's a real problem or it's a fake one.
I wanted to ask one last question. Does thermography has its role for non-metallic structures like FRP tanks inspections or
Yeah,
condition assessments?
yes, definitely. If you say as a entity person, FRPs are the worst to deal with any other entity method. We cannot do radiography. We cannot do ultrasonics. Very limitations. We can do, but very limitations. We can only do through transmission or something like that. It is non-ferromagnetic, so MPI is out of question. Non-conductive, so eddy current is out of question. If we want to check the integrity, because of being a porous and adsorbent surface, leak test will also pose a problem. If we can refer to, there are only, we can funnel down to two methods. One is acoustic emission and one is thermography, that can assess these FRP structures in proper and fruitful manner. But as you see in acoustic also, we are trying to load and break the structure to here for cracks. So again, there is some limitation. So that leads to only one method, that is infrared and thermography. Lot of advances have been made in active thermography field to identify cracks and flaws in such FRP or laminated or composite structures. So for composite, I can say that thermography is one of the best method that we should explore before applying any other entity method.
Well, Krutik, this has been a very rich discussions. Friends, at TCR Advanced, we use thermography extensively. If you have any thermographic related questions, do visit our website at www.tcradvanced.com, or you can write to us on info@tcradvanced.com. Till then, stay safe and thank you.